Up next, we have a second conference of the day. The next team from Littleton, Massachusetts are the developers of Advantage Scope. They have around 20 blue banners. How amazing is that? And they have been participating on Einstein Field for 3 years in a row. Please give a warm virtual welcome to Jonah from Team 6328 Mechanical Advantage.
Thank you very much, and thank you very much for having us. I'm just going to share my screen here.
Sure, go ahead.
Just a minute. Okay, looks like I'm going to have to rejoin the meeting. This will take a moment. Okay, there we go. Yes, so thank you so much for having us. And good morning, everyone. Thank you all for coming. So this presentation is called The Power of Data, and we're going to be talking about data logging, data visualization, and all sorts of important tools for modern FRC. So my name is Jonah. I am a software mentor on Team 6328 and the lead developer on Advantage Scope, which we'll be talking about a little later. Okay. So here's the stuff we're going to be talking about today. Starting off with the levels of logging in FRC, we'll go through how to get started with logging, what Advantage Scope is with several case studies exploring in more detail how to use it. We'll talk about merging data sources with several more case studies. And for those of you who might have already used Advantage Scope, we'll be talking about things that are new this year that you might want to take advantage of. Okay, so first, we're going to be talking about data logging, but it's important to break down what that can actually mean. And we like to think about these three categories that you see on the screen. So let's go through each of those in a little bit more detail. First of all is level 1 logging or driver station logging. This is built right into the FRC driver station, and it works automatically with no setup required. So that records simple data, things like battery voltage, your current draw, network diagnostics, and console text. That's really useful for simple issues. You might have seen FTAs use it for field diagnostics, but it's not very customizable. You basically get whatever data is logged automatically. So the next step up is to do onboard logging, and this means recording data from the RoboRio to a USB drive. You can also do network streaming, so if you want to visualize data live, you can stream it from the robot in real time. And there are now lots of different options for doing onboard logging in FRC. WPILib has built-in tools for logging data from your code, and both CTRE and Rev have options where you can log data directly from their devices. Take a look at that a little bit later. Now, this is much more customizable than driver station logging. You can basically record whatever data you want, anything that would be useful for debugging. The main downside that it has is, of course, you need to make sure to log a field that you want to view. If you forget to log a field, you won't be able to look at it later from a log file or live streaming. Right. Now, in order to address that issue, there's also a concept called log replay, which is level 3 logging. That's even more advanced than what we're going to be talking about today. But if you're curious about what log replay looks like and what it can do, we presented a session at the championship talking all about it. So we'll have a link to the recording to that at the end of the presentation if you're curious about it. Okay, so now we've discussed what logging can look like in FRC, but let's dive into a few specifics. Now, if you're only using driver station logging right now, that would be level 1 logging. I cannot recommend highly enough that you explore level 2 logging. Remember that includes both network streaming and log files. There are now so many options for doing onboard logging in FRC, and all of these require just a few lines of code to get started. So it's really easy and you have nothing to lose. So I'll have more links to more information about all of these at the end of the presentation if you're curious about the details. Now, first of all, WPILib includes a whole bunch of tools for logging data from robot code. That could be everything from joystick inputs and or your odometry pose to the state of your subsystems, PID error, things like that. Now, network tables is WPILib's standard protocol for publishing data to the network, and the data log manager class can capture all of your network tables data to a log file. So I think that's the easiest way to get started with robot code logging. To the right, you can see some example Java code for what this looks like. There are 3 lines in robot init to start the data log manager and epilogue and capture driver station data. So that includes your robot state, joystick inputs, things like that. You can then publish anything you want to network tables. With manual logging, it's easiest to do that just with the Smart Dashboard API. You might already be familiar with that. And WPILib new for 2025 includes an annotation logger called epilogue, which means you can add a method, like you can see this get value method, that just returns a double, and WPILib will automatically log the output of that every loop cycle if you've enabled epilogue. So that makes logging easier than ever before. And there are a whole bunch of data types supported for this. So you can log primitives, arrays, or even complex types like geometry objects, poses, things like that. So it's a very flexible tool, and there's a lot of stuff you can do with it. Now, in addition to WPILib, there are now several options where you can log data directly from vendor devices. CTRE includes what they call their signal logger for Phoenix. This captures data from some of their devices to the Rio. That includes the Talon FX, Pigeon 2, and CanCoder. It's really easy to set up. You can see that to the right in Java. And in fact, if you don't add these lines, the signal logger is also started automatically whenever you're connected to the field. Though I do want to note that with the signal logger, in order to access the majority of signals, you do need a Phoenix Pro licensed device on the CAN bus. So this isn't one that you get for free. Now CTRE also includes a diagnostic server on the Rio. No setup required for that, but that allows the signals from all of their devices to be plotted over the network. And that feature does not require Phoenix Pro, so make sure to take advantage of that. Okay, now Rev as an alternative does not include an official logging option for their devices, but we've developed an unofficial solution for logging data from the Spark Max and the Spark Flex. It's called Urkel, the unofficial Rev compatible logger. And again, it's just a couple of lines to set up. This captures data from all of the Spark Maxes and Flexes on your CAN bus, very similar to CTRE's signal logger. All that data is sent to network tables for live visualization, and it can be captured using Data Log Manager, just like any manually published data. And of course, Urkel is free and open source. Okay, so we've captured all of this data using numerous tools. And so how do we visualize all of that data? Well, there are several options for that. And what we're going to talk about today is Advantage Scope. Advantage Scope was a tool that was developed by 6328 starting in 2021, and it's currently included in the WPILib installer. Now, Advantage Scope is a programmer's tool for data visualization, and all of the levels of logging we've talked about today are supported. So everything from driver station logs to network tables and WPILib logs, CTRE logs and their diagnostic server, and Advantage Kit logs for the most advanced users. Now, Advantage Scope supports both network streaming and log viewing in one application, so you don't need to recreate your visualizations or switch between 2 tools when you're analyzing log files. And Advantage Scope has a whole bunch of visualization tools built in. Here's a complete list of all of the tabs that it supports, all the visualization options. You can see there's everything from basic views like line graphs and tables, up to complex views like the 3D field, joystick view, and swerve diagram. And many of these views can also be combined in useful ways, which you'll see in some of our case studies. It's really easy to get started with Advantage Scope. Since it's included in WPILib by default, chances are you already have it installed. So just go to Start Tool in VS Code and choose Advantage Scope, and it'll open right up. You can also download Advantage Scope directly from GitHub. If you do it that way, there's support for some additional platforms, as well as more example robot models that you can try out on the 3D field. Advantage Scope also has extensive documentation available. If you open the app and go to the upper left, there's a book icon. If you click that, it'll open up our documentation, which includes how to interact with different data sources, how to use each visualization, how to import custom assets, and a whole lot more. So that's a really useful resource if you're getting started, and I would encourage you to consult with that. Okay, so that's sort of the basics out of the way, but I want to take a look at a few actual case studies so that we can see what data logging looks like in action and why you might want to pursue it. So this first case involves the tuning of an arm. And for context, this is 6328's 2023 robot called Banana Split. It consists of a triple jointed arm. So there's a shoulder joint, elbow joint, and wrist joint. And all of those joints need to be controlled via a feed forward model and a PID controller, which of course needs to be tuned. So let's take a look at how we can analyze the arm behavior with Advantage Scope. This is a log file from one of our 2023 events. What I'm going to do is drag out the measured and set point angles for the elbow joint, and then zoom in on the match so we can get a closer look. You can see I've also included when the robot is enabled along the bottom. Now these units are in radians right now, so let's fix that. We can go to the unit conversion menu and switch from radians to degrees. It's often much easier to visualize in familiar units like degrees, so Advantage Scope can convert on the fly between common unit types. Now we can see looking at that graph, the angle is tracking pretty well, but it's kind of tough to visualize what's going on here. So we can also log the arm state using a mechanism 2D object. That's built right into WPILib, so you might already be familiar with it, but Advantage Scope can view mechanism 2D data from a log file. Here I'm going to open up a mechanism view, drag out the set point and measured positions, and here we can play back the log in real time and see what the arm was doing. Now this is fine, this gives us a better picture, but it's still a little bit abstract. So let's go to another Advantage Scope view. This is the 3D field. Advantage Scope allows you to import your robot CAD for visualization. And here we can see the same data on the robot model. We've also combined it with odometry data so we can see how the robot is moving. And here the translucent robot represents our set point. So this makes it much easier to visualize exactly what's going on with our robot. And we can also connect using network tables in order to view all of this data live. So for example, during driver practice, we can watch the set point versus the measured position of the arm in order to ensure that we're tracking accurately. And here's one more visualization of that data. We can make a histogram by having Advantage Scope automatically calculate the absolute error based on our measurement and set point fields. So you can see, for example, the average error for the elbow across an entire match. In this case, our mean error is about 1.5 degrees, which is pretty good. And our 99th percentile is 7 degrees. So we might try retuning the arm and seeing if these numbers improve, for example. And speaking of retuning, let's say we weren't satisfied with that performance and we wanted to improve things. Now this robot was set up to accept PID gains over network tables, which means we can connect to the robot to easily adjust gains on the fly. So I'm going to enter tuning mode in Advantage Scope. And what's happening right now is we're running an auto routine to move between different positions and plotting the wrist measured and set point position. So as I change the KP value and the max acceleration, the robot responds in real time, and we can see exactly how well that wrist controller is tracking on the graph. We can even use techniques like this to tweak the code live during driver practice. For example, during a shooting game, we might want to adjust the flywheel speeds up and down based on the performance during when the drivers are really moving around the robot. So it's a great way to see the effects of tuning under more realistic match conditions by tuning in real time remotely like this. Okay, so for our next case study, we're going to move on to talk a little bit about vision processing. Vision is an area where good logging is really critical for diagnosing issues because most of the pipeline for vision is things that you can't see directly. Now, for context, we developed a custom April tag tracking system called Northstar. The goals are similar to Limelight or Photon Vision that you might have used. We're trying to estimate the robot pose based on visible tags. Now, our 2023 and 24 robots each have 4 cameras. This first example is going to be from 2023, so we can take a look at the performance of that system. Now, here we've gone to a bird's eye view of the field on the 3D Field tab. And what I'm going to do is drag out some robot poses or drag out some fields for our individual robot poses and the list of visible tags. So here the green lines show which tags the robot is detecting, and the translucent green robots show individual pose estimates from the cameras. Now, right now we're running an auto routine, and you can see as we get closer to the April tags, we detect more of them and have more pose estimates coming in. Now in teleop, we're going to switch to run faster than real time. So here, if something went wrong during the match, we can quickly speed through and find where the problem was, where our pose estimate might be a little bit off. And again, we can view all of this data live over the network, for example, during driver practice. But we don't need to stick to just a bird's eye view. We can also recreate the video from each of our 4 cameras based on the robot's position. So this allows us to see when tags should be in view of each camera. And we can even see which mechanisms might be blocking tags. Like, for example, one of our cameras on this robot was sometimes blocked by the intake in certain positions. So we can try and debug that. And one more visualization of the localization data, we can create a heat map of the robot's movements throughout the match. That's useful both for analyzing the localization accuracy and for doing match review with the drivers to see what lines they're following and where they're spending more or less time. Now, we've been looking at a few examples of 3D visualization, but we can push that even farther. AdvantageScope can visualize game pieces in 3D, which allows for a whole bunch of potential applications. One of those is visualizing auto routines, either in sim or from real logs. And here you can see some examples from the previous 3 years. These are all using relatively simple animations, but you could also get much fancier with this. For example, if you're modeling shot trajectories or doing physics simulation of game pieces, you can display all of that in AdvantageScope. So this is a really useful feature if you're trying to simulate an auto routine, for example, but you don't have a robot yet. Game piece visualization can be even simpler than that too. Here we're just showing whether a game piece is inside the robot based on a sensor value. And this involves just publishing a single pose from the periodic method of your indexer. So it's really quite simple to get started with this. Okay, so now I'm going to go in a slightly different direction. We've been talking about AdvantageScope for a while, but AdvantageScope is not the only tool available for visualizing logs. System identification is another powerful tool that's available in WPILib that you can take advantage of with logging. Now, system identification is the process of determining a mathematical model for the behavior of a system through statistical analysis of its inputs and outputs. So what are we talking about there? Well, inputs to a system are usually things like voltage, and the outputs might be your position or velocity. So the point of sysid is to try to relate inputs and outputs mathematically. A common example might be that given a desired velocity and acceleration of a flywheel, as an example, we might want to calculate the required voltage to achieve that state. This is called a feed-forward model. We said that's a mathematical model. Here's a simple example. This is converting a velocity and acceleration into a voltage. And there are 3 gains, Ks, Kv, and Ka. Ks is constant. It only depends on the direction of the velocity. This is accounting for static friction. Kv converts velocity to voltage, and then Ka converts acceleration to voltage. The WPILib docs go into more detail about why this works if you're curious. And sysid also works for more complex mechanisms. So how do we determine these gains? Well, you can model them theoretically, but the performance of that is often pretty poor in practice because friction in the real world can be unpredictable. So instead, we can measure these gains using log data. WPILib has built-in tools to run system identification, and it needs to gather data over a series of 4 routines. The first step is to configure it in code. All of this goes in your subsystem class. So you just define a setter for voltage and getters for voltage, position, and velocity. And then you have 4 tests, which are defined as commands. Now, there are 2 quasi-static tests we have to run, forward and reverse, and 2 dynamic tests, forward and reverse. It's also possible to use CTRE and Rev logging directly, so you can consult the relevant documentation if you're curious about that. So we've created these 4 tests, and here what we're doing is looking at how voltage affects the velocity and acceleration of a drivetrain. This is a very common use case for sysid. What you're seeing right now is the quasi-static test, where we're going forward, and in a moment we're going to go in reverse. Here we're slowly ramping up the voltage to check how that affects the velocity of the wheels. Um, there are also dynamic tests, so you go forward and reverse, and here we step up the voltage suddenly in order to measure how the robot accelerates. This type of characterization is also applicable to other mechanisms. You could run this on a swerve, flywheels, arms, etc. Yeah, so there's a dynamic test, you see. Okay, so using all of the callbacks we defined, all of that data is saved to a log file, which can be browsed in AdvantageScope. It records the test data, so that's shown in blue here, and we're looking at the position of a swerve module during each test. So you can see we slowly ramp up during the quasi-static test and accelerate more quickly during the dynamic tests. The final step here is analysis. This is where we calculate the values of Ks, Kv, and Ka based on the data. What I'm going to do is open up the log file in the SysID analyzer and then select the fields that include the test state, the measured velocity, position, and voltage, and then we'll configure the mechanism type and units. In this case, we'll do a simple mechanism, and we're measuring in radians. We load the data, and then you can see right here we have the calculated feed-forward gains, Ks, Kv, and Ka. And there's lots more to dig into here. There's many things on the screen, so I would encourage you to check the SysID documentation to learn more about the other information here. After applying those new gains, we can then check the performance of our drive in AdvantageScope. And when tuning a swerve drive, we have a built-in visualization for that. You can see that on the right, we're showing the measured positions in red and the set points in blue. We're also showing the set point and measured speeds on the left, so we can compare. And you can see that it's tracking fairly well, which suggests that our system identification was a success. So hooray. Now, everything that we've talked about thus far involves using a single log file or a single source. But there are lots of potential sources of data that we're interested in. Those include log files of different forms, WPILib logs, driver station logs, CTRE logs, and external data sources like Match Video and Zebra MotionWorks. All of these sources need to be loaded and synchronized. And AdvantageScope can do all of that automatically. So there's no need to manually sync up log files or switch between viewers to understand all of this data. Now let's start with a simple example of data merging. This is kind of a follow-up to the April tag case study we did a few minutes ago. Now, Zebra MotionWorks is available at some events to track robots on the field. The way this works is that there are two tags mounted on each robot. You can see an example of that to the right. And there are sensors around the field which are detecting the locations of the robots. The data from Zebra MotionWorks is published to the Blue Alliance and available to all teams. So it's useful for analyzing overall match play, but we can also use it to check the robot's localization. AdvantageScope can automatically download and merge Zebra data at events where it's available. We just click one button under the File menu, and AdvantageScope automatically finds this match on the Blue Alliance and loads the relevant Zebra data. So here, the positions of all 6 robots are visible on the field. So the green ghost is our Zebra pose. And as we play back the match, we can compare our onboard pose to our Zebra position to see how accurate we are. Here's a different way to look at that data. We're graphing the X components of our built-in localization and the Zebra data. And you can see these are synced up pretty well, but where we're most interested is when we have the greatest error. And one place is near the end of the field near the nodes, right here. And in this case, it actually seems to be an error with the Zebra data. Here, you can see an example where the robot's onboard localization is in solid, and the Zebra data is in green. So in this case, I don't think the robot was inside the nodes, so this is probably an issue with the Zebra data. But another spot with issues is right here. And this is where we collide with another robot and cause our wheels to slip. Here's what that looks like. So we collide with citrus circuits on the field, our wheels slip, and it takes us a moment in order to relocalize and figure out where we are, which is totally expected with this sort of system. But overall, if we look at the trend, our tracking seems to be quite accurate, which suggests that our onboard localization is doing very well. So that's a nice confirmation. Now, another example of where you might want to merge a data source is when it comes to match video. Because when things go wrong, it's really important to distinguish software problems from driver error. That allows you to solve the issue more efficiently and prevent it from happening again. comparing logs to video is a really great way to review matches this way. So here we have a log file, but we really want to see what the robot was doing. Match videos are automatically uploaded to the Blue Alliance in many districts, so let's sync the log. On the Video tab in Advantage Scope, I'm going to click the TBA icon, and the correct match is fetched automatically. The video download starts, and once enough of the match is loaded, it will be automatically synchronized to our log file. That's accurate to within about a frame. So there was absolutely no manual work required here. Everything was synchronized and ready to go automatically. Now that we have that video, we can open another useful view. This shows the state of all of the joysticks during the match. This type of joystick data can be logged automatically by WPILib. And as the match plays, we can see what the drivers were doing moment to moment. This allows us to much more easily distinguish between code problems and a driver who just pushed the wrong button, which has happened a few times when we're in early driver practice. Okay, so now I've focused in on one moment near the end of the match. I'm going to replay this at 25% speed so we can see more clearly. Our robot is on the bottom of the screen racing back towards the hangar when we hit the cable bump and go clean over. So this is a moment that we'd certainly like to avoid repeating again. So let's replay that and get a closer look. So here, pay attention to the joystick on the driver controller. Right as we hit the cable bump, the driver releases the joystick, which means the top of the robot keeps moving, and we land so the robot tips. After a really difficult moment like this in a match, log data can allow the driver to review their actions in detail and understand exactly how they can improve. So in this case, the driver never made that mistake again, even in future years. So this is a really great example of how logging isn't just valuable for programmers, but also for this type of match review. Here's another example of that. We can merge the same data source across multiple matches to get a better look at how we're doing at an event. So here, we're going to merge the logs from playoffs at our first 2024 event. So you'll see I'm going to select about 5 log files, and then we'll begin loading all of this data. Advantage Scope will automatically sync up all of the matches, so they're aligned. And we're going to start replaying these 5 matches together in auto. Now during auto, we can see the 5 robots are relatively consistent. There are a few outliers, so maybe we hit other robots on the field or got stuck on a game piece. Lots of things can affect your path during auto. But during teleop is where things get interesting. We're going to play faster than real time here. You can see overall our lines going back and forth between the source and the speaker. We're sort of going all over the place. We're taking different routes each time, so we're not being particularly consistent. But let's compare that now to our second 2024 event. So here we're going to start playing back in auto. And this time, first of all, you might notice there's more variety in auto here. So we're starting on different sides of the field. You can see here we go for 2 different centerline notes. But the robots that are running the same auto are still consistent. Now, let's take a look at teleop. Here, as we get into the bulk of teleop, you can see our lines are much more clear. And you can see when we're doing feeding cycles versus scoring cycles. And we're following the same consistent lines. So this is a sign that we had a more refined strategy at this event, and the driver was more practiced and able to execute on that strategy. So again, this is an example where logs aren't just useful for programmers, they also allow us to better understand strategy and help drivers improve. Okay, now we have one last thing to talk about, and this is specifically for anyone who might have seen this presentation before or is already familiar with Advantage Scope. So this may be of particular interest to those folks. Now, every year we update Advantage Scope to add new features and capabilities. And this year we have over 130 new features and updates. So there's a whole bunch of stuff to play with. And I'm going to talk about some of the more notable additions that you might be interested in. So first, we've observed that teams are producing increasingly large log files as they log more data, which is great, but it revealed an issue with Advantage Scope. So here we're going to open a very large log file in Advantage Scope. And you can see that it takes quite an extended period for us to open this file. This process can slow down iteration if you have to wait this long when opening each new file, particularly in the heat of an event. So one of our main goals for 2025 was to speed up that process. Here's what it looks like to load exactly the same log file in the 2025 version of AdvantageScope. So the decode time went from 30 seconds to 300 milliseconds, which is over 100 times faster. So we hope that comes in handy and helps you iterate on your log files faster. Another common issue that we heard from users is that on tabs like the odometry view, it can be difficult to scrub precisely in order to analyze data on smaller timescales. In order to address that issue, we completely redesigned the timeline interface to make it more capable and easy to use. You can now zoom and pan just like the line graph, and autonomous and teleop periods are color-coded to allow for easier navigation. You can jump to the start and end of match periods and zoom quickly by clicking and dragging with the Shift key. So it's much more capable. Hopefully that's a nice improvement. We also redesigned the control interface for almost every tab to make it more simple, consistent, and capable. There are new configuration options on almost every tab, which are easier to access than ever before. Many object types have new colors, like additional colors for ghosts, and nested objects make it easier to customize advanced behavior, like having multiple robot objects on the 3D field. We've also added first-class support for struct types. That allows 2D and 3D poses to be intermixed on tabs like the odometry and 3D field views without any risk of mixing up data types or mixing up units. So that's a really nice enhancement too. Here's another example of some new unit types. We have several new options this year for swerve visualization. You can visualize swerve states on the odometry and 3D field tabs, or see chassis speeds on the swerve tab for debugging kinematics. And another fun addition is heat maps on the 3D field. Not only can you look at heat maps up close in 3D, we have new range options too. So you can filter to only auto, only teleop, or only teleop without endgame in order to avoid any data that comes from climbing. You can even set a custom range and pan through the match manually. So lots of fun stuff to experiment with there. There's also a nice set of improvements this year to the console tab, like highlighting for error and warning messages, highlighting of text when filtering, and the ability to exclude unwanted messages from the view, like periodic warnings. Okay, so now on to the feature that we are most excited about, and that is AdvantageScope XR. This is a new feature that allows you to visualize the 3D field using augmented reality, and it's really easy to get started. All you'll need is a desktop host running AdvantageScope on any platform. You'll need an iPhone or iPad running a recent release of iOS. No apps need to be installed ahead of time, though, and both devices need to be connected to the same network. Now, our goal with this was to streamline the setup process as much as possible. So here's what it looks like to connect to AdvantageScope XR. You scan a QR code displayed in the desktop host, open the app, and then just follow the instructions at the bottom of the screen to position the field model. For example, here we have a miniature field, but we have options to visualize the field in both miniature or full scale. So let's take a look at some examples of that. Here's a really simple example of miniature visualization. Now, this sort of thing works with both log files or a live connection to the real robot or simulator. What you're seeing here is match 5 of the 2023 Einstein tournament, combined with zebra data that you saw earlier. So we can walk around, we can see from different perspectives, even take a look at the match as you would see it from behind the driver stations. So a very neat visualization of data that you can view on the 3D field. Here's another visualization where we go from miniature to full scale. So this is a simulated auto routine running at life size. We can walk around and see that routine from any perspective, even if we don't yet have a robot built. So for example, you could simulate an auto and watch it in full scale on a practice field. So we hope that comes in handy too. Here's another example of full-scale visualization, and this is one you might find useful during kickoff this weekend. You can walk around a full-size field model like this, or overlay virtual elements on a practice field. So this allows you to get a closer look at the field and get a better sense of scale by seeing the field elements in person, even before you build practice field elements, for example. And one final example, using full-scale visualization, you can overlay data on a real robot. For example, say you're setting up a simulator for an arm mechanism, but the physical mechanism isn't built yet. But maybe you have a kit bot up and running. Well, what you can do is overlay a mechanism 2D on that kitbot model in order to test auto routines or teleop driving and see what that mechanism would look like when driving around a real robot. So we have this seamless blend of real and simulated mechanisms, which is useful when you're in the midst of developing your design. So those are just a few examples. For more details and potential use cases for this, I encourage you to check the documentation page. You can see the link on screen right now. And we're really looking forward to seeing what everyone does with this feature in 2025. I know we have some team members that are very excited to get their hands on this too. Now, in summary, here's the stuff that we talked about. We went through how to get started with logging, how and why to use Advantage Scope, the benefits from merging multiple data sources, and a quick overview of what's new in Advantage Scope in 2025. And here are some links to some of the tools that we've talked about. You can also contact us by emailing software@team6328.org. So I appreciate you all listening in, and I think we have a few minutes if anyone has any questions. Yes.
Thank you. Thank you very much for those QR codes. Possibly they are going to be super helpful. Yeah, we are about to start a Q&A session. So we have two questions here already. So from an anonymous assistant, Advantage Scope can be used for FTC robots.
So Advantage Scope isn't officially supported for FTC. It's something that is built into WPILib, is designed for FRC, but it supports custom field models, custom field images. So if you wanted to import field models from FTC or VEX, for example, you could support that as long as you log data in a compatible format. We'll certainly be looking more at FTC compatibility in 2027 with the unified control system, though.
Okay, thank you. Okay, we have a second question. What data do you generally recommend to log so that I don't log data that I may not use from an anonymous assistant?
Yeah, so I would say the key things that you want to log are certainly everything that WPILib logs built in. So things like robot state, joystick inputs, those are all extremely useful. And then in particular, anything that's related to vision, things like pose estimates, that's something that normally would not be very visible. So that's a high priority to log. And then generally, I would focus on sensor inputs. So things like encoder positions and velocities, some of that you might get from vendor logging for free. Um, if you have subsystems that are based on state machines, that's a really great thing to log. But a lot of this also comes from trial and error, that you log some things, do driver practice, for example, and then you discover there are things that would have been useful, and then you can add them to the code. But that's really an iterative process to make sure you're logging everything you need.
Okay, thank you. This is another question from Alex Gael Favela. He asks, how many time do you think would take for someone to learn properly to code an autonomous robot and use programs like Advantage Scope?
Hmm. Well, so getting started with logging in particular, which is one piece of that, is really very easy. I mean, it literally takes maybe 5-10 minutes to set up the code that I showed for level 2 logging. And then you just connect a USB stick. Um, the more broadly, developing reliable autonomous routines, using some of the more advanced features of Advantage Scope, right? That's again a very iterative process that you can start with doing very simple logging, doing simple auto routines. Current tools like Path Planner and Choreo for doing auto routines have extensive documentation, so it's fairly easy to get started with the basics of that. You can also find lots of great code templates online for that. Um, but then it's all a process of improving. I mean, improving over time. 6328, we're always looking for new ways to improve our autonomous capabilities, to push the limits of what we can do with data visualization. But getting started, I would encourage you to check the relevant docs in particular for setting up autonomous routines, since we didn't really talk about that today. But getting started with all of these concepts doesn't take